And so we're going to talk about something called the modernized forecast operations concept today. And we're going to have a couple polls, the same address and text number we've been using all morning. And we're going to talk about this forecast concept. And I want to preface it with a couple things. One, nobody has all the answers to this, but one of the things as you all know, we've been talking a lot the last couple of years about the move to more probabilistic based science and services. And as we do so, we have to kind of think about what our job looks like going forward, right? What is operations going to look like as we move into this paradigm? And there's a lot to wrestle with. And so there's been this very broad discussion going on that we're going to talk a little bit about amongst all the CONUS regions, and we kind of want to share some thoughts with some food for thought with you all today, and leave you with this to ponder after this seminar is over. So let's go to the first poll, Andy. And so the first question is, just what is your comfort level with communicating probabilistic information to our partners? And I know this may vary on the partner and that sort of thing, but just how comfortable are you? We've done, the foundational probabilistic training this last year. We went through that. There's been vignettes shared. There's been the science sharing presentations that Andy does have a lot of probabilistic. Your local office, your SUs have been providing this information and working with you all in a variety of ways. So we're just curious, how comfortable are you communicating the kind of probabilistic information with your partners? We also had the probabilistic messaging testbed that we had about 10 offices go through last year. So let's see the results, Andy. Okay, that's great. I would agree with the 9% that say it depends on the partner and or information being shared. That makes perfect sense. Really happy to see that we've got 75% that are somewhat comfortable or very comfortable. That's really good. And then we have a small amount that are very uncomfortable, and that's fine. We're all going through this transition together, and we're learning. We're kind of changing the tire on a moving car, I like to say, as we're kind of learning how to share this probabilistic information. So that's great. Thank you so much for participating. So go ahead, Andy, to the next slide. So what we're going to be talking about is there's this document called Building a Weather-Ready Nation Through Science-Based Service. It was largely written by Matt Jeglum in Western Region SSD and Caleb Steele, but it was had input from all of the CONUS SSDs, and we kind of worked on this together, although Matt was the primary author. And the idea is to kind of create a vision, right, for moving forward. And there's a clear need to evolve, and Andy and I are going to hopefully kind of lay the foundation on why that need is there, and why now is the right time to be doing this. So the idea is to revolutionize our ability to protect life and property and enhance the economy of the United States by fully leveraging probabilistic information that is now at our disposal, which really wasn't at our disposal, 15 years ago. And there are several reasons for why the time is right at this point in time. And the justification for this change, not only do we have this data available to us, just having the data doesn't make it right for us to move this direction, right? It's because people make better decisions, they have higher trust in the information that we provide, they display greater understanding of forecast information when they are shown probabilistic forecasts instead of a deterministic one. And this is not just in weather, this is across a variety of disciplines, whether it be health, whether it be natural hazards, all sorts of communication. There's all sorts of social science research that shows that this is the case. And then we're going to talk about that today. So Andy, let's go to the next poll. This is an interesting one. So the NDFD forecast should represent which of the following? The most accurate forecast, the most likely outcome, what the forecaster believes is most useful, best forecast for the user, the NBM, or other. All right, I think we're ready to go forward, Andy. You've had enough responses? Yes, great. Yes, most accurate forecasts, most likely outcome, best forecast for the user. I'm glad there wasn't, I'm glad C didn't get any or very few votes at least, or the NBM. So yeah, most accurate forecast, most likely outcome are kind of what I think most of us think when we look at the NDFD, that's what it should represent, right? So let's go to the next slide. And we're going to talk about kind of the challenge of the deterministic database, right? So what should we have on the grids anyway? This is a slide that Matt Jaglin put together that I'm just going to speak to. So all our forecasts are actually a PDF, right? When we put out a deterministic temperature forecast, it's coming from, if there's a PDF for that temperature forecast. But what we're doing is we're taking that PDF and trying to identify a deterministic number that represents the PDF. So we often say our deterministic forecast is the most likely, and there were several people, or a good number of people said that that's what the NDFD should represent. However, does it really represent the most likely outcome when we have a pop that's say 30% and we have QPF with it? Because the most likely outcome of a 30 pop is 0 QPF, but we put a QPF in anyway, right? So if we have a 30 pop and you have 1500ths of QPF in there, that's not the most likely outcome. So if we want to do good DSS, there's no overall best deterministic forecast, because the forecast, it depends on the application, right? It depends on what the user needs it for. So on the right is an example of kind of the mode, and say the mode in that example at the top of that graphic is 1.5 inches of QPF. And the median, 50% above and 50% below a value is say 1.9 inches. And then the mean is actually, say, the average is actually 2 inches. Right, and so you could have, if you're making a deterministic forecast, do you give them the mode, the median, or the mean? They're all different numbers, right? But they don't represent accurately what the PDF is showing there. So maybe you take the mode at the top and you look at that orange horizontal line, and you say rainfall is expected to be between 1 and 2 inches. And if you hit advanced one time, Andy, however, there's a 20% chance that we're going to get more than 3 inches, right? That's a much more useful forecast than saying 1.7 or 1.5 inches. You give the user what the most likely outcome is, right? The range that it's most likely to be in based on the mode and what's around the mode. And then you also give them the probabilistic information about what probably exceeding potentially significant value is. So we're kind of framing this discussion in this way. The deterministic forecast is there still, but we're providing more information with the probabilistic information. And I'll turn it over to Andy to take over for a while.
All right, thanks, Randy. And so, as Randy discussed here, there's problems with the deterministic forecast and what we're trying to do with probabilistic. And it's very interesting, the research on probabilistic. It goes way back. For those that have been in the Weather Service for a while, you may recall when we did the switch from text-based forecast to graphical forecast with the advent of IFPS and GFE. Well, Cliff Mass from the University of Washington wrote this article in Weather and Forecasting right around the time they were migrating to graphical forecast, and mentioned, this is totally the wrong way to go, because especially beyond 12 hours, we should be doing this in a probabilistic ensemble-based framework, because why try and put out a single number for, let's say, a high temperature on a day 4 or 5 forecast when there's oftentimes a plethora of uncertainty. And really, as Randy just showed, it's for a partner that may not be enough information to give them, or it may not even have enough value for that partner. So Cliff Mass wasn't the only one stating this. There's a whole plethora over the last 5 decades of research across, most of these are AMS type journals, whether it's BAMS or the Journal of Weather and Forecasting or something like that. But you see it across all of these, that there's a need to move to probabilistic information and to help us provide increased value and trust to our forecasts. So as stated here earlier, our current problem at hand is that we are providing deterministic forecasts through a variety of services, such as the ZFP, the grids, and point and click. Furthermore, we utilize a lot of words of estimative probability, such as possible, good chance. So unfortunately, this causes the public and our partners to put their own error bars and make their own interpretations of what we mean. Here's an interesting study. This is from an NWA journal from 2020. Where a group of participants, I think it was on the severe weather application side of things, were providing values to these words of estimated probability. And there's such a wide spectrum for what they mean. Something I think of for fun is to just try to catch yourself on how many times you use the word possible in products, and just see and hear how vague possible actually means. You know, some people think it's just a 10% chance, while others think it's 80% chance. I'm going to shift gears for just a moment here and just take a look at how forecasting has evolved. You know, you go back to the very early days of forecasting. A lot of it's just kind of rules of thumb, knowing, okay, maybe this little specific weather pattern can yield this. But then over time, we just build up all these conceptual models. We learn those. And then we have models get developed. You go from the LFM, NGM, ADA, and I'm probably bringing back some old terms that many of you remember. And now we're to the, you hear the NBM, which is this robust ensemble and has post-process probabilistic input, included within it. So, we've developed quite a bit, and all this evolving has happened because we've had advancements in science and technology. Something like probabilistic that we're bringing up wasn't possible, even probably more than a decade ago, because we just didn't have the science and technology power here behind it. But now it's here. So, you may have seen this quote many times here from Alan Murphy that, weather forecasts possess no intrinsic value. But if you go through the same paper there, Alan discusses 3 main points that make a good forecast. One is consistency, which essentially means message into what you know, no hedging. Second is quality, what we utilize to help improve our forecasts, verifications related. And the third point is value. Ask yourself, what are you providing? Is that helping your stakeholders make decisions and take appropriate actions? So I really wanted to put everything together here, service-wise, plus incorporating this more probabilistic aspect here to help increase value in our forecast, requires a modernization of our forecast process. And this is laid out here for you in a 4-step process. And note that both science and service are firmly integrated within this process. And we're going to step through each one of these. The first is something I think a lot of us do already, is to, you do a quick situational awareness, what's going on with the weather, looking at your observations, radar, satellite, but also taking into account what have you been messaging, for the over the past, 6-12 hours, and does everything still align with that messaging here going forward? Then we go through that process of populating the NBM, just like we currently do here, and try and figure out what are the potential scenarios that we have to consider. And there's no picking a winner here in this process, which I think is kind of different. In this deterministic mindset, you feel obliged that, oh, I got to pick some winner in here because I got to provide that most likely forecast. But here's where that probabilistic comes into play, is where we have to start thinking about what are some alternatives that could happen. Also thinking about, as mentioned here, the probability of an extreme outcome to occur. Now, our next step here is where we really want to get at the partner engagement. I want to come back to what John Gordon just mentioned, is that probabilistics of here is all about relation. It's not probabilistic, but weather alienation is all about relationships. And here's where we are going to apply that relationship knowledge and knowing, okay, what are the thresholds that our partners really, really care about? They may not match what we have in our directives for our watches, mornings, advisories. And so that kind of may adjust what your target, if you will, for both any potential grids and mostly, especially messaging, what that will be. And then finally here is, communicate what you want your partners and everybody else to hear. What we deliver in our traditional services may not be enough. And furthermore, you may want to actually get out numbers on that uncertainty and say, not just saying that there is some uncertainty on this upcoming severe weather event. You can actually start to provide that numbers, because we are now starting to have a big enough data set to do that. I will say this whole concept of delivering probabilistic information is not entirely new. In fact, from the national level down to local level, you know, shown here, we've been doing it for a long time. It's not just thinking, it's thinking bigger. What other probabilistic things could we provide? So here are some examples that I'm shown here on the screen that we might be able to deliver either now or in the future. And all of this comes about working through that partner engagement. What are their decision points? What will cause them to have to take a different action? So I want to pass this back to Randy to talk a little bit about this.
Thanks, Andy. Yeah, I want to, you know, we kind of have been sharing some broad kind of statements about how users interpret information more accurately and make better decisions when they're given probabilistic information. So I just kind of wanted to share an example instead of just kind of hand waving and saying, yeah, this is the way it is. I just wanted to share one study that is an example. And there's many more like this. But this is basically a simulated road maintenance decision making done by Dr. Jocelyn and McCurk at University of Washington. And they asked the players in the game essentially to make a salt brine application decision. So they had to apply it before it reached 32 degrees Fahrenheit, and the decision's based on the nighttime low temperature. So they did 60 cases, 2 months of data, and the cost of treating roads was $1,000 if you treated, and the cost of not treating and temperatures went below 32 was $6,000. And so they had people make a decision every day based on the different scenarios. And so go ahead and advance to the next slide, Andy. And so what they did is they had a deterministic group and a probabilistic group, as you'll see on the right there. And so here's an example of a forecast. The expected nighttime low temperature of 35 degrees Fahrenheit. That's the deterministic forecast, right? So then that person has to make a decision whether or not to salt the roads. And then the probabilistic group is expected nighttime low temperature of 35 degrees Fahrenheit, same deterministic forecast, but a 20% chance of less than or equal to 32. So they had to make a decision based on that information. So they're given the same deterministic forecast, but a little bit of probabilistic information as well. So what they found is that the probabilistic group made better decisions. They had 2 times more money in their budget at the end of the 60 days than the deterministic group, and they had greater trust in the forecast information that they were given. And this is a great example of the kind of studies that are done. And these aren't like high-level, you know, partners or statisticians or anything like that. These are a variety of participants in these studies. And this is shown over and over. And this is why we really need to include the probabilistic information in addition to our deterministic forecast. And one example I love is that, and I don't know, this may not work for non-baseball fans, but baseball managers make decisions all the time on where to put their players in the field. And this is something that's been going on, I don't know, last 10 years or something. So if you have a left-handed hitter come up and they have a really strong propensity to hit the ball to the right side of the field towards first base, second base, the right fielder, what they'll do is they'll move a player from the other side of the field onto the right side of the field. And this is based on statistics, right? That they're more likely to get an out by moving a player across to a non-traditional position on the other side of the field and leave a big gaping hole on the left side of the field because they're more likely to get an out. Now that manager doesn't have to know anything about statistics at all. Doesn't have to know what a PDF is, doesn't have to know what a t-test is. They just have to know that they have the best decision for them is to put players in a certain position to increase their likelihood of an out. And so that's what's shown with probabilistic information is if we present probabilistic information in a nice simple way, people that receive that information don't have to have like a really high level of understanding of statistics and probabilities and that sort of thing. It's really about the way it's presented. So I just wanted to share that example to kind of give you one example, at least to back up some of the things we're saying. So I'll turn it back over to Andy.
All right, thanks, Randy. So a big key here is that we have to admit no one has all the answers here. You know, as shown earlier, probabilistic data, while we've been delivering some, is still in its infancy. You know, more science, tools, and training are needed here. But what must be understood here is that just because we're shifting probabilistically doesn't mean it has to be complicated. And Randy gave that great example, you know, on the baseball side of things. And in fact, here's an example on the weather side where you know, the Gaylord office here providing probability of 4 inches of snow or more you've got both presented here, the percentage values and where they sit with various terms, low, medium, or high. That combination has been recommended by social science, that if you provide a term like low, medium, high, put the probability in, and vice versa. So very well done with that example. And so many of you might be wondering, okay, what does this all mean? What happens to the deterministic forecast? Well, we still have to provide that. It supports our current services. Many users still need that, and then maybe many will still want that for many years to come. I mean, that's what they're used to. However, I think the social science here coming out in that is saying we need to move probabilistically, and that provides us with such more useful forecasts, much richer material. Also to note here is that the deterministic forecasts that we're given, they can easily be derived from a probabilistic database. I think Randy was showing that earlier here with the PDFs and where you might assign a deterministic forecast. In fact, that's a lot of how the MBM works too. The reverse cannot be done, where you create probabilistic information off a deterministic database. It's sort of a one-way street. So a challenge again as we go forward here is how to, is maintaining this deterministic database while we evolve towards this probabilistic-based service. And kind of want to end you here with this final quote, and this goes back to that same paper here. It's out of an NWA journal from Lenhart et al. And I'm just going to read right off. Probabilistic information enables better decisions, higher trust, and greater understanding of weather information than deterministic information. And we also know that unqualified terms, example possible, can lead to wildly different interpretations on the user end relative to what the meteorologist has in their head, leading to poor decisions. And that will conclude our talk, and we will open it up for questions, unless, Randy, you have any final comments.
I do have one final comment, Andy, thanks. One thing that we want to make clear is that this isn't Andy and I talking. This is all four CONUS regions working together conceptually to think about the direction we need to go. And so there's no walls really between the regions on this topic. And the document that we're kind of discussing has been endorsed by all of the CONUS regional directors and shared with national STI director as well, and he also supports it. So this is a broad effort. There's not like a clear roadmap to how we get from point A to point Z, right? We're going to have to learn together and be creative and flexible and that sort of thing. And we've been keeping the steady cadence of probabilistic information, probabilistic sharing and tools and ideas, and we'll keep that going. We've been doing that for the last couple of years, and we'll keep moving forward with that. But I just want to make that really clear that this is really a joint effort, and we'd like to share this document with everyone. Some of you may have already seen it from folks like that shared it with you from another region or something like that. So we're hoping to get it shared with everyone soon. But for now, we wanted to at least present some of the concepts within it. So thanks for listening, and Allie, we'll turn it over if anybody has any questions.